All right, Stephen, it's the beginning of 2025, and historically, there has been one event that has dominated January more than any other one, and that is the Consumer Electronics Show. But don't let the C part of that fool you. There is a lot of technology that's announced at CES that is not necessarily consumer focused, that has impacts on the entire industry. There's two stories that we really wanted to dive into that kind of plot a trajectory for the way that 2025 is going to go. The first one, Nvidia. That's it. That's the whole story. No, I'm kidding. CEO Jensen Huang, who, by the way, was lucky enough to get a selfie with Pat Moorhead of 6 5 Live. He was the keynote speaker for CES 2025. And I know what you can guess he talked about. It's bringing AI into the real world. They also talked about their new Cosmos World Foundational Model. NVIDIA aims to enable AI systems to understand and interact with the physical world. The Cosmos model, which has been trained on 20 million hours of video data, will be freely distributed through Hugging Face and the Nvidia GPU Cloud. Huang also recommends that organizations adopt a 3-computer AI system, which naturally is all powered by NVIDIA, and suggests a future where AI and robotics will disrupt traditional economics and labor, which I'm sure was very well received by that audience. This also includes Project Digits, which is a desktop system for AI application development, and the Llama Nemotron family of open models for building agentic AI applications. Stephen, I'm pretty sure I just hit my AI buzzword bingo card for 2025 and 2026, but help us make a little bit of sense of what everybody's favorite rockstar AI god talked about during the CES keynote.
Well, first of all, those of us who are watching the keynote were absolutely blinded by Jensen's incredible, shiny alligator skin leather jacket. He's gotten a jacket upgrade to go with the AI chip upgrades as well. But looking beyond that, let's talk a little bit about what he's talking about here. First off, kudos to NVIDIA and Jensen Huang in particular. This keynote was as visionary as anything you'd see from any tech company today. And that's good and also a little bad because, as you mentioned, the content of the keynote was very much, hey, guess what, pathetic humans, you're no longer needed here. Well, at least that's how some people were taking the keynote, because truly what he was talking about is the power of the next generation of AI systems is pretty mind-blowing. So think about it this way. So far, we've had large language models that have been able to convincingly produce text that seems like there's thought behind it. Now, the jury's still out on whether there is or is not thought behind it and whether these systems are actually exhibiting emergent behavior or simply convincing us that they are. But it doesn't really matter if it's good enough. Essentially, if you're able to create a simulation of reality that's good enough to fool everyone, then it might as well be reality. And that's sort of what NVIDIA is looking at doing next. What if, instead of just taking text and inputting and outputting text, what if an AI system was trained on essentially physics and the real world around us? And that's what NVIDIA is trying to do here with the Cosmos model. Essentially, just like they did or others did with LLMs, they're trying to do that with the real world. So the idea would be that you could train a system to understand things like gravity and object permanence and physical dimensions and things like that. And that would solve a lot of the problems that we're seeing right now in a lot of the AI generated content out there. So, for example, if you've played around much with some of the AI video synthesis systems, they're really good, but also really bad because they actually have no real understanding of the real world. They're just pretending to. So sort of like earlier versions of ChatGPT would sometimes just completely go off the rails with their responses. These video synthesis systems also just completely go off the rail. And for example, you'll see a synthetic video of a car driving that way, and then suddenly the front and the rear end morph backwards, and it's suddenly going backwards and the other way, or something like that. That shows that it just has no concept of reality. The same thing is true of basically any kind of AI generated video at this point. And what that says is it says that the model simply has no understanding of the real world, or at least no way to convince us that it understands the real world. It's just making fake pictures. What NVIDIA is trying to do is enable a future where AI models would have the ability to build basically a fake version of the world, and then build video or interactions or robotic systems based on the constraints of that virtual world, and apply those to the real world. So that's all well and good when you're talking to some of the demos that they showed, for example, of convincing photos or videos that don't have six fingers on their hand, or different sized things, giant bunnies, or whatever. All of this is much more constrained to the real world and much more convincing. But then what they're talking about, and this is what makes it visionary, is apply that to the real world. So you have this digital twin of the world where AI can learn and explore, and then you can apply that to things like robots and autonomous vehicles and so on. And in fact, this is how many previous self-driving systems have operated: is they build a digital twin of the world, and then they apply rules in that digital world and then bring them into the real world, so that cars don't make stupid mistakes like these video generators would. Uh, so that's sort of what NVIDIA is looking at doing here. It's a very cool, it's very visionary, and it's very not something NVIDIA is going to do alone. Now, what are they going to do? Well, they're going to sell a huge amount of processors. NVIDIA is already the most valuable company in the AI space by far. NVIDIA says that the acceptance of their next generation processors has just been absolutely off the charts. Another thing we're not going to talk about, because this is enterprise tech, not consumer tech, is NVIDIA showed their future consumer graphics cards and GPUs. Absolutely cool stuff. Check out your favorite consumer tech space for reporting on that. Um, so NVIDIA is basically saying companies need three computers or three new systems. They need a DGX system or a similar system from an OEM, which is what's used to train AI models. And these things are big and expensive and power hungry. This is that AI supercomputer that we've been talking about. Of course, they're a lot less power hungry, but a lot more expensive in this next generation world. Now, NVIDIA amused us by showing a wafer scale chip, which is not something that they're actually going to create. I think Cerebrus would have a thing or two to say about that. Instead, what NVIDIA is delivering is their NVL 72, which is their big honkin' interconnected rack scale AI supercomputer. They also talked about a second needed requirement, which would be a training system, which would allow companies to build this omniverse physical world, and explore that. And then the third thing they would need is to have factory, warehouse cars, robots, etc., also using NVIDIA processors out there. So between the three of these things, essentially, NVIDIA has a much bigger total addressable market. They've got much, much more that they can offer. And I think they're hoping that that's what they're actually going to do. But, uh, what did they actually announce at CES? Well, what they announced was basically an AI PC that's built on the Grace Blackwell ARM slash GPU chip that they've already been shipping. Uh, that thing is going to be a pretty nice desktop system. I can't wait till Jeff Geerling gets his hands on one to run some benchmarks on it. The other thing they've talked about is massively expanding the availability of models. So they've taken Llama models and basically enhanced those, put them up on Hugging Face. They've got models from other companies as well, all in the effort of basically giving the software that's going to be needed to run on these AI PCs or AI workstations in order to enable the people, like us, to develop the next generation of AI applications. This is a lot. It's a lot to take in. It's a lot to digest. There were a lot of other things that obviously announced at CES, including new laptop chips from Intel and AMD, including a lot of really cool GPU technology from AMD and from Nvidia. Tom, talk to us a little bit about some of your other takeaways from CES.
It sounds to me like Nvidia is gearing up to make a mountain of money. And I can't blame them for saying that, right? Like they have sold a ridiculous amount of hardware to people who are essentially using the infiniteness of technology to build slightly better autocorrect. I mean, that's kind of what you're looking at with the GPT model. And Jensen kind of said that to that effect. Like everything so far has been focused on GPT, and that's not how the real world works. Like you've mentioned, it's the interaction with things. It's, building a digital twin of a warehouse so that the robots know where to go pluck things off the shelves. Every time you talk about what that's going to take, just add more processing power and more processing power. We joked around a lot in 2024 about how the thing that may save the U.S. nuclear industry is AI. I'm at the point now where I'm thinking that AI may be the thing that creates cold fusion because it's about the only thing that's going to supply enough power to these models when you think about it. And the fact that NVIDIA is now saying, well, no, you don't just need Blackwell in the cloud to run all of these wonderful things. You need things at your desk that can do that for you. And you need these development kits and you need to buy more hardware from us. And that's really the key that they're trying to get to is they've realized that you can't build a big enough system. I mean, for goodness sakes, their current half rack unit requires water cooling. It's the only way that it's not going to turn your data center into a sauna, and even then it might actually do it. So I think that Nvidia is seeing the same thing that Intel saw years ago, right? Like we are seeing a maximum for what we can do with the performance of a unit. What we've got to do now is we've got to back that performance off and split it across multiple units. In Intel's case, they came up with the core concept, right? Multi-cores on a die. Nvidia is now saying, well, what if I took that concept of decomposing what we do in a giant Blackwell cluster into systems that can sit on somebody's desk? Now, remember that there is a wide gulf between what you're going to be doing with, I don't know, stable diffusion or pick your favorite AI generator of video or images or whatever, and like what a warehouse scale thing would be doing or what, digital twinning the world would be doing. And I think that NVIDIA needs to do a better job of drawing that distinction between the two. Because remember, we're not quite 2 years into this AI revolution. And so far, the massive use of AI to write term papers and create insights into my life hasn't actually done a lot for the end user. They've been sold on this promise of what AI can do, mostly by companies like Nvidia who are trying to sell as much AI hardware as possible. And it's paid off handsomely for them. I saw a quote just this last week that 50% of the people that work for Nvidia are now worth at least $25 million because of the stock price. So they've done well for themselves. But how can they continue to grow? Because eventually you're going to hit a limit, right? And I think that's what Jensen's trying to say is in order for us to continue to grow, we have to sell more systems to more people to do more stuff with AI as we upscale what AI is capable of doing. And I think that that is one of the key messages that you have to take away from this. It's time to break away from writing term papers. It's time to, and essentially the most truthful way to say the old idiom of where the rubber meets the road, it's time for the AI model to meet the road and figure out how to make this stuff work with things that we can touch and use every day.